First off, thank you for coming to listen to me ramble on about JavaScript metaprogramming. It's a pretty dry topic. I'll talk about it for about an hour here. I appreciate you guys coming in and taking your time. I genuinely hope you've enjoyed the conference as much as I have. Hope you've been able to get some great information out of sessions. I'd like to thank the NDC organizers and sponsors for getting us back together. I'm sure you guys are all tired of hearing. We're glad to be back together, but it's a lot of work to put on a show like this, and I think the NDC organizers are world class, and just wanted to publicly thank them for putting together this and getting us all back together. So with that, I'm Dave. I am a lead software engineer for the back end of a small company back in Indianapolis, Indiana called Vibenomics. And what we do is the background music and advertising you hear in grocery stores across the United States. So there's actually, it's not just like somebody sitting in the back room pushing play on Spotify or something. They get sued for that. So there's actually a whole industry behind that, and I handle the back end side. So I was saying a little bit before we started, I came into JavaScript. I had done JavaScript years ago during the browser wars and all that. That was really my experience with JavaScript. And when I started at this company, I was a .NET developer. I was a Microsoft MVP for 5 years on Visual Studio and development tools. I got into that through some of my work with F#, and F# changed the way I program. So if you think about a statically typed functional programming language going to JavaScript, like, talk about a paradigm shift, right? F# has flavored everything that I have done since then. And when I started at this company, I came in to stabilize our old product that's now retired. And I was on contract, and I fell in love with the company. So when they decided that they would keep me on to start working on this new project, but the decision was, oh, but by the way, we're going to do it in Node, I was like, oh, that's a little bit of a shock. So, but all of my memories of what JavaScript was back during the browser wars were completely unjustified, because JavaScript is not the same language it was. And now I'm going to approach this talk from my perspective as a Node developer. So if you're primarily front-end, I think you'll be able to get some mileage out of this, but I don't do front-end development, so I can't really talk to how it plays with the various compilers or Babel or any of those. I'm sure you'll be able to use most of these, leverage most of the techniques, but I have not personally tried them. But yeah, so if I was doing JavaScript the way it was during the browser wars, I think I would have changed careers. But now, with ES6, we have so many robust capabilities that it is absolutely a different language than it once was. And one of the things that I think really has evolved and matured over the past several years is our ability to do metaprogramming. So who's familiar with the idea of metaprogramming? Okay, so half the room. So we always hear about metadata, but metaprogramming is programming about programming. So how can we make our code understand itself and adapt and evolve itself? That's what metaprogramming is. And when you understand what metaprogramming can bring to your project, you can think in different levels of abstraction and generalize things that would normally be more single-case, single-use opportunities. So for this talk, we're going to go through a number of the techniques that are available to us in modern JavaScript, but we're going to start going way back in time. So with that, we fall into 3 categories for metaprogramming. The first is code generation. And I'm going to say right up front, I never do this in JavaScript. JavaScript doesn't really need it. It has capabilities for it. They all suck. The first one, the obvious one, eval. Don't use eval, right? Yeah, I don't. I'm not going to go into the discussion on why not to use eval. It's well documented. Even the MDN documentation says, don't use this. Use some other things instead. But the idea is you give eval a string of JavaScript, and it throws it out to machine code and compiles it every time you need to do anything with it. Every time you run eval, it needs to do it. There's no keeping it around. So it also has some scoping issues and whatnot. But yeah, the idea is give it some code, it runs it. Don't use it. Let's skip through this. And I'll say that a lot of these early examples and the historical things, I'm going to kind of gloss through because it does get a little repetitive, but it's all building up to some of the ways that we can apply the modern interfaces to make our code a little bit more self-reflective, so to speak. So then we don't use eval, we get the function constructor. Similar idea, solves some but not all of the issues with eval. I have yet to find a need to do it, just based on the nature of JavaScript, but it does isolate your scope a little bit better, and it doesn't form closures around things like you would potentially see with eval. But yeah, you call the function constructor, you pass it the parameters that it's going to accept and the function body, and it takes care of the rest, and then you can treat it like another function. Hey, surprise, new function gives you a function. But it doesn't close around things, as I mentioned, so if I have const name outside of my function constructor, it doesn't have visibility into that. So the output of this is going to be name is not defined. So it gives us that little bit better isolation. And for the Node developers, we have the VM module, which suffers from many of the same problems, but it does give you some better isolation than the function constructor or definitely eval. Not going to go into this a whole lot. It is just another option for how we can dynamically add code to our system. Where things start getting interesting in metaprogramming is in the idea of reflection or introspection. So this is looking at your objects. What is the structure of your objects? What data types do they use? And how can I manipulate those? So we've always had some capability for this in JavaScript. The in operator is one of the oldest operators in the language. Got an object defined, it has 3 properties, first name, last name, and age. And then I can use the in operator. First name in my object? Well, yeah, it is. I can see it. Last name in my object? Yes, it is. Middle name? No, it's not. And in has another use. Probably seen the structure where we have a for variable in. This allows us to look at all of the properties on the object. So if we run that and we push all of those property names into an array, we get an array of those property names. Hey, surprise. But we can take it a little bit further. Even in the old days of JavaScript, we could use that for more practical things than just saying what is on here. We could use it to copy values around. Now, all references and pointers and everything else that come into play are still a factor, but if you're needing to transform an object perhaps, or change from one model to another, that was a potential way to do it. It was a little bit more verbose than the ways we have today, but it was certainly an option. We could remove properties with the handy delete operator. I was asked, why would you ever need to delete a property? One of the cases I've had is the system that I work on is primarily event-driven, and we want to capture when a user has changed certain aspects of their user profile. One of those aspects could be a password. I don't want to capture the password on my event log, so I strip it out with something similar to delete before I write that model to the database. And delete does exactly what you'd think. So then if we have age and we delete age and we delete middle name, which doesn't actually exist, hey, look, but delete returns true anyway? So that's one of the shortcomings of delete, because it did something. Well, no, it didn't, but it completed successfully, so therefore it definitely deleted something. But age we had defined, we deleted it, and now age is no longer in my object, so that one at least tells us the truth. and start to see a theme with some of these older interfaces, these older operators and statements that you'd see in the very early days of JavaScript. Type of. You need to understand, do I have a string? Do I have an object? Do I have a function? That's where we go to type of. Last time I said this, people on Twitter got mad at me. Type of lies. Now, it doesn't really lie. Everything up here is the best kind of correct, which is technically correct. But you have to understand more about how the value was initialized than one would necessarily think, especially if you're coming from like a .NET background and you ask for type of, you expect it to give you a consistent answer. But if, depending on how your value was constructed in JavaScript, type of can give you something that is only technically correct. Type of string gives us string, but type of string constructor gives us object. Now, if we're in our own code base, we can control for this, right? We know we're not going to call the constructor. So we can be pretty assured that that if we call type of and our value is a string, that we should see string. But I know that we don't all work in silos. We don't always have our own code. We pull in NPM packages all the time. How can you be assured that what you're using, what an NPM package is giving you, is constructed in the way that you construct everything in your code base? So type of, while it can be useful, is generally best avoided. And I personally use the functions from Lodash that do the same thing. MDN has some discussion about the pragmatism of type of, and it actually provides an alternative implementation that you can use, which I looked at it. It looks pretty decent, but I use Lodash, so I didn't care that much. But if you need to understand what your data types are, type of may or may not give you the answer you're looking for. So we looked at these things. We see that there's maybe some problems with some of them. They did what they were supposed to do, but not necessarily as predictably as one would like. Especially me coming from a functional background, I like to make sure that I have things like referential transparency. So I want to see that if I call a function or if I delete a property and it's going to tell me that it deleted something, I want it to have actually deleted something. So we come in to a new round of things. We get a whole new series of functions, most of them hanging off of the object type. We get things like define property, where rather than just manipulating the contents of the dictionary or hash table, whatever you want to call it, the object, where you can just dynamically attach things, we now have an entire interface for how to define that. Not only do we get to control the name of what we put in this object, we get to control various aspects that the interpreters and the runtimes understand. So things like the enumerable property, which controls if you were to do an in against the object, whether it is actually listed or not. You can control that aspect. You can make them read-only. And as you'll see later, there are ways to control how you get or set those values. We get a nice function called getOwnPropertyNames. So anything that is enumerable on that object will come back in an array. So if we call object getOwnPropertyNames on this object, we see that we have the two that were defined on the object itself directly, and then the next two that were added programmatically through the reflection operations that are defined on object. And similarly, we have keys off of object, which are the ones that so actually, I'm sorry, getOwnPropertyNames includes the non-enumerable ones, and keys is just the enumerable ones. If we look at define property for middle name, enumerable was false. It is not in the keys. So there's a distinction between those two, and I missed that. I apologize. And let's see, we already talked about that piece, so I'll skip over that. Again, part of this gets a little repetitive, just watching this evolution. So property descriptors. I talked about enumerable a bit. I talked about writable. We want to provide the value. Well, that's conveniently named as value. And configurable, I can't remember what it does. I meant to look it up, but I don't remember. I have not had an instance where I actually needed to set it, so generally I just leave it at the default. We saw a little while ago the getOwnProperty names, and we saw keys. Well, we can also do object.values. And so this will iterate over the properties on there and give you the value of them, and not just, so instead of getting the name, you'll get the value. I find things like this being useful if I'm trying to convert to a CSV, for instance. I can get the property names once, and then I can get the values on each object in my array, provided they're the same structure. That can be convenient. But where things start getting really interesting is bringing back both of those pieces of data, the keys and the values, together. So define our object the same way we've been defining it, add a couple of new properties. Then we have the entries function. The entries function gives you an array, hence we're calling map, an array of keys and values, which you can then operate against as you please. So in this case, I just map them into a string and join it on semicolon, and so the output of this is first name is Dave, last name is Fancher, age is 42. So we can get those pieces of data. We're starting to see things about how our code is structured and the values associated with that structure. And if you've done this, where you've got entries, maybe you've written that off somewhere, and you want to reconstruct your object. Well, you get object from entries on that, which does the opposite direction. It will recreate an object based on those key and value pairs, so you don't have to do it manually. And I think in this one, yeah. So then we get object assign. So given some object, put the properties and values of another object into it. So in here, I've got my object, and I've got an empty object, and I pass in my object along with it, and we get a new object that has the copies of the first object with a new value being added into it. So when we've done the clone, we do object assign. We start with that empty object. This is the object we're going to put stuff into, and then we're going to copy those values. Whatever is on that other object, what's visible from that object, gets added onto this new object, which paves the way for merging objects. And that's object assign. So we had object assign here with an empty. Now we have object assign with something with some values in it. So maybe you have two different data sources that have parts of a data structure, and you want to put those back together. Well, object assign, I have core object properties, like some user profile perhaps, and then maybe some posts. It's an array. I can merge those together easily through object assign. And these are great. Like all of the things that we've talked about that hang off of object are great. They're incredibly useful. But in ES6, we got yet another API that takes a lot of the lessons learned from those object-based functions and gives us a bit more consistent interface, if you will. And these are all defined in the reflect type. So there's a lot of overlap between what we've seen on the object functions and in reflect. And in fact, many of these, like the define property, have the same signature. They take the same parameters. So if we look at this, instead of calling object define property, we're calling reflect define property. We're telling it what object to affect, which one we're going to mutate, what our new property is, and then we have that descriptor with our configurable true, enumerable true, and our value. And it does exactly the same thing, but it does it in a little bit more consistent way. It gives you, the differences are really that, and I forget which one does which off the top of my head, one of them throws a type error, the other doesn't. I meant to refresh my memory on that, but they behave differently and in a little bit more predictably as you're working with them. And because I'm in ES6 and these are available in ES6, I tend to favor these over anything that I saw and talked about on object. Right. And so while object didn't have a delete features, there's no object.delete property, there is a reflect delete property. This behaves more consistently than the delete keyword that we looked at before. So if you need to remove a property, reflect delete property will do that for you. Reflect get, reflect set. So we're just looking at the functions that control reading and writing to properties. I never use these. They're kind of redundant. They tend to make code a little bit more verbose because, let's face it, it's JavaScript. I can go in and do a dot and an equal, and, and we accomplish the same thing. So I don't tend to use these, but they are there, and it's nice to be aware of them. But enumerating properties, remember our friend the in operator. This is the basis of how I write a lot of my introspective code on my platform. This serves a very similar purpose of in, except that it gives us an array of those properties. So in here I've got similar structure that we've seen before. I did use the object version of define property here, but reflect own keys against my object gives us that array. We don't have to do a for in to get these values anymore. We just get the array. And if we have an array, that means we can map against it, we can reduce against it, we can filter against it. That leads us into all sorts of composability possibilities that can change the way that you structure your code. Similarly, with in, we have has. So reflect has, my object and the property name, give you a true or false. And as I was saying, we get into this composability. So I have this function here. This is a very naive implementation for demonstration purposes only, but this is a way that we can start building some more generalized functions for handling validation and keeping our logic separate from our data. As a functional programmer, I don't want to merge functions and data and classes and all of that pollution that comes with classes. I want to keep these separate. I want to treat data as data and functions sometimes as data, but usually independent of the models. So in this, I've got a higher order function, and that's important to that because this leads again to composability. So familiar with higher order functions? Okay, I don't see something, there's a lot of hands that didn't go up. So higher order functions are functions that accept or return another function. Think filter, think map. And think reduce, the one function to rule them all. Pretty much everything that we have in terms of these array functions, whether it's map, whether it's filter, whether it's sort, it's all a reduce. That's all it is. They're specializations of reduce. So this function called validate model accepts a validation model, which is just an object that has some properties, but instead of having values of actual data values, they have functions as values. And then it accepts the model that we want to validate. And we use reflect own keys against our validation model to know what properties we want to validate. And we reduce against those, essentially looking to see if the value in our model satisfies the predicate from the validation model. We'll see an example of this on the next slide. If we have any failures, we throw an error and we don't proceed. Otherwise, we return the model. So a helper function and then an implementation. Now that higher order function comes into play here. So we're calling validate model, and we're passing in not the data that we want to validate, but the way we want to validate that data. I've written that validate model function exactly once, because the act of validating something is almost always exactly the same thing. We know we have some rules that our data model needs to adhere to in order to enter our system. So now I've codified the rules. I have first name needs to be a non-empty string. Last name needs to be a non-empty string. And age needs to be a number. So again, naive, simplistic, but this is the basis of how I structure my code with and using these metaprogramming techniques. So what is the validate person model? Anybody? What is the value of the validate person model at this point? It's a function, right? Because validation model goes to, model goes to, so it's a function that still wants to accept our model. So we can invoke validate person model, giving it our actual data model. First name satisfies is not empty string. Last name doesn't. And age is a string, so it's going to fail, and hence validation failures are last name and age. I can take code like this and hand it to a non-technical person and say, are the rules right? And they can say, if I've named things properly and understandably, they can say, yeah, that looks right, or what are you thinking? And there's some power in that, because the code is now more expressive, because we've abstracted away all of the extra stuff that we have to write, all the boilerplate stuff we have to write to express what rules are in our system. We now just have a list that follows the structure. And we'll come back to this example a little bit later. Actually, I think I have to just jump into it now. Let's do that. Let's switch this. Okay, nope. Yes. All right, let me blow that up. Is that visible in the back? All right, cool, thank you. So this is an extension of that example that we just saw. The code is the same. I added a couple of extra things into here. So I'm using, I'm in Visual Studio Code now, and what I'm using to drive this is as an extension for VS Code called Quokka. I don't know if you've heard about it, but it's a fantastic tool. It's essentially a REPL for JavaScript that gives you some additional testing capabilities and just an all-around really useful tool. So we've already looked at the validate model. This is, again, the same code as before. But we can apply the same concepts to transforming our data. So say that we have a web page somewhere, somebody's filled out a form, and the browser provides the data in one structure, but we want to transform it to a different structure. We can use these reflection techniques in a very similar manner to what we just saw with validation to do the transformation as well. So this particular function, transform model, I'm sorry, yes. So transform model, they're starting to see a pattern here. We have transformation model, goes to reflect. This time, we're reflecting on the transformation model, and we're reducing against those keys. So if I've defined a key on the transformation model, it will appear in the target, the newly transformed model. So we're going to project our model from one structure to another. And the body of that is get the transformer, get the source value, define a property on the target model, just iterate over those through reduce, as reduce does, and return it. So then I get two functions below. I define a function validate user model, which, hey, that looks familiar. I changed it from age, but it's birth date now. And we have transform user model. There's a theme here. I have first name, last name, birth date, age, and what do they take? What are their values? They're functions. In this case, the value, so as we try to read a value with the same name off of the input model, we pass it in as value. And we also provide the source model in case we want to have something else from that source model available in our transformation. When we see the code in a minute that runs these two together, we do the validation before we do the transformation. So we know if we meet our validation rules, we know that we're in a structure that we can transfer, that's safe to transform, and then we can apply the transformation. So now transform model, first name, oh, we're just trimming it. We already know we've got a string because it passed validation, so we can just trim it. Last name, okay, trim it and go to uppercase because arbitrary reasons. Birth date, we can convert to a date and we can take the format. If it was in one format, we can translate it to another. That's all I'm doing there. And, oh, why not? Let's just calculate the age too while we're at it. So we don't have on our user model a first name property, a last name property, or an age property. We do have F name, L name, and birth date. So we can see the validated model is what we saw before, and transformed model takes that validated model and applies the transformations. I'm going to run this, and we'll see in the output window the top group here is the result of our validation, and then the bottom object is a result of our transformation. Does that make sense? Okay, I'm going to jump back over to the slides for a bit. All right. Hello. Okay, apparently the presentation and the display got out of sync when I did that. All right, there we go. So who has encountered symbols in JavaScript? Okay, only a handful. So guy doesn't count. Symbols are one of my favorite things in ES6. So what symbols allow us to do is define they are a guaranteed unique value. Let's start there. So you are not going to have a collision with something else naming something the same way, because every time you create a symbol, it's unique to JavaScript, to that instance and that environment, right? They are intended as extension points, essentially. So you hear things, prototype pollution, evil, right? Well, and I think back on my time in earlier days of JavaScript, and well, no, don't extend certain things because you're going to have a collision with some other library is going to name something the same way, and everything's going to step on each other, and the last one in wins. Symbols work around that problem. So we can define a symbol and attach it to an object, and then we have a safe extension point on that object. So in this case, we just do symbol, it's a function, not a constructor. We can pass in an optional label, helps identifying it in the debugger. That's about all it does. Kind of lets you differentiate as you're writing things out in console and watching its various traces and whatnot. It does carry that description with it, but that's about the only value that serves. But it's generally nice to attach it just so you know what you're looking at in the code. And there's the global symbol repository, I believe that's what it's called, where you can register symbols to be shared more commonly across code. So then, and there's a use case for that we'll get to in a little bit. So when we can define our own global symbols, we can toss our own symbols into the repository. So this one I'm calling symbol for. This is the for function puts that in the repository. And if I do a comparison, if I say global symbol, which I've just defined, is actually equal to the one that's in the repository. If you were to have something else, if you were to do symbol without calling for and go my global symbol, that is not the same symbol. Every call to symbol gives you a new symbol. So simple case for using these. Define a symbol, which I'm just labeling as greet, and have a function called say hello. I'm going to attach say hello to an object with a bracket syntax because it's an expression value. It's not just a name. It's actually the key is the symbol. And then we can invoke that function as we would reference anything else more dynamically. Just put it in brackets, make it look like an array. This case isn't really all that practical, just to shows how you can attach, one of the ways you can attach a symbol and what the symbol is useful for. But they are an integral part of modern JavaScript because there's a whole series of what are called well-known symbols. And these well-known symbols are, for the .NET programmers in the room, very, very conceptually similar in use to how a lot of the built-in .NET interfaces are, because they drive a lot of the syntactic sugar. Things like modern in are driven by symbols. And you can customize how your objects behave with things like split and search by tapping into the well-known symbols that the modern JavaScript runtimes know about. In this case, I'm using the well-known symbol, which is exposed as a static property of the symbol type. It's called toString tag. How many times are you debugging something and you see object, object, and say, wow, thanks a lot, JavaScript. I'm glad you know what that is. ToString tag is one of those well-known symbols that is actually understood inside of the JavaScript runtime that controls how that string is constructed. So instead of object, object, I'm attaching symbol ToString tag through reflect define property to my object, and the get, this is part of that descriptor for that property, the get function returns just the interpolated version of two of the properties. So instead of object, object, I get object with my name in quotes. That's more useful than object, object. Now I'm able to make more sense of the code. I know exactly what I'm working with. And all it did was take attaching a symbol to it. So one of the things I really like to do is abuse language features. I've yet to find a language feature that I didn't like to abuse. Symbols are one of them. And did anybody go to Mark Seaman's talk yesterday? So Mark Seaman talked about fractal architectures and trying to construct your code in such a way that you limit the complexity of your functions to essentially what the typical human can keep in their head. So the usual, the mantra of 7 plus or minus 2, right? Well, as we start building out our systems and they become more complex, it's nice to be able to reduce that surface area. And I think symbols in JavaScript are a great way to do that. So take this function, another higher order function. Attach symbol accepts a target and a function, and then it returns a function that accepts a function that does something, returns a symbol. We create our symbol, we attach it to our target object through reflect define property. It's not enumerable, it's not writable, not configurable, but the value is just that function. So just like what we did back here, we're just doing this as a function. So we can start attaching symbols that are just defined as we need them, and we return that symbol. So now we have a reference to that symbol, which allows us to do things like create a function called attach symbol to object prototype, which the target is object prototype. And because everything comes from object prototype, we can make things more generally available throughout all of the objects in our system. And from my functional programming background, I like the pipe. I like functional pipelining. I want to take a value and let it flow into a function and let the output of that function flow into the next function and so on. I don't want to write code where I have to name variables or constants that have a life cycle or a lifespan of one line of code, because that's something else to keep track of. So I can attach a symbol to the object prototype. I'm going to call that symbol pipe. I refer to that as pipe throughout my code. It's pretty simple. It's a function that takes a function and returns the result of applying whatever object has been extended where pipe was originated, applying the function to that. Any ideas why I'm using the function, the classic function syntax here instead of arrow functions? Sorry? This, exactly. This is the one place I use a classic function extension, or use a classic function. Like in most of my code, I avoid any type of scoped functions because that just leads to temptation of writing code that has implicit external dependencies, and I don't want that as a functional programmer. I want my function to be given directly and explicitly everything it needs to do its job and give me a value back in a predictable manner. So here, as I attach that symbol, now I have my object. Pipe was already attached to object prototype, so as it tries to resolve that name, it's going to go up the tree, up the prototype chain. It's going to find that symbol, and I'm passing a function in which does some transformations, and this is essentially writing a log message. But I don't have to keep track of that intermediate stage because I know what my input is, I know what my transformation is, I can transform it again, and I can transform it again. And it's just a step of operations, and there's no capturing of variables because we already have a variable defined for these things, right? It's not on the screen. But this is the variable, what we would put it in. So we just let it flow into the next part of the chain. It reduces that surface area. Okay. So if we go back to VS Code, how am I doing on time? We're doing, I'm pretty good, it looks like. Let me go back to VS Code and we'll revisit that last example. So that example we just looked at with transforming and validation. We have our validated model, which gets the result of validate user model, and then we have transformed model, which gets the result of transforming the model, and so on. By applying that function, extending object prototype with that symbol, we get rid of a lot of those extra variables and things. We have less to keep track of. And again, we've got just a checklist of things, the series of steps that our code is running through. We still have variables and parameters in place, but it's allowing us to define things in a way that is a natural flow. And nothing in here is non-standard JavaScript. Like this, symbols are part of ES6, right? All of the reflection capabilities, we didn't use NPM to bring anything in. Those are all things that are just natively part of JavaScript. Reflect own keys gives us that ability to look inside of our objects and see what is there and apply operations to either those keys directly or obtain the values related to those, we do that same thing over and over and over. That's half of what programming is. It feels like we get some value, we got to do something with it, right? This allows us to get those generalizations, and we know that we're applying things in a consistent manner. Okay. All right, let's see if I can do this and not have it lose my state. There we go. Okay. So that's largely the reflection and introspection part. But then we have the third part of the metadata triangle, and that's intercession. So intercession is where, well, while reflection is acting upon the data and understanding the structure and working with that structure, intercession is actually intercepting behavior and doing and manipulating the built-in behavior. Before ES6, there really wasn't a whole lot of capability for this, but ES6 gives us a little bit more capabilities here. I actually should have just stayed in VS Code. I was thinking I had another slide. So ES6 gives us some additional capabilities. And we've seen some of this, and I forgot to extend. What is going on? Come on, duplicate, there. Sorry about that. So object-defined property gives us some of that intercession capability. We saw a hint of it earlier when we saw get on something. When we define a property using defined property, and that's the reason I like to use defined property instead of just saying dot some new identifier, because we can control those aspects. We've talked about enumerable, but get is when we read a value, what happens? Normally, it just gives you the value back, if it has it, or it gives you undefined. What happens when you try to set a value? Well, normally it's just going to put it in the dictionary or update whatever is already there. But through defined property, we can define get and set and control what that behavior actually does. So in this case, I've got an object function called audited object. Inside of that function, it's tracking a context and a log. So what this is doing, based on its name, oh, we're going to apply some auditing here. I want to know when people read a value or write a value. And you could redirect this as you would see fit in your code. I'm doing console log for demonstration purposes. We can see when we get a value from an audited object, we'll log out getting context first name, and then we'll return the value of first name from that context object. Likewise, when we set it, we provide the value. You see here. We log out that we're changing that value. We set it on the context, and then we push that change to our log. So not only have we written out to the console log, we're managing a history of what those changes were. I think that's pretty common. So I defined that as first name, and then I defined it very similarly on last name. And then I defined a property called history, again against this. And here, we only have get. We don't allow setting history, because what good is history if you can rewrite it? So then we can create an instance of the audited object, and I'll run this in a moment so we can see it. We can write out, we can get the history, and this is I meant to mention this earlier, the /e's and the question mark is Quokka, and how it will automatically log things out when we run it. We can see what we call, where we set the first name and the last name, we write them out, and so we're going to see a bunch of logging that goes along with this. So let me do this. Run once. So we got a bunch of things written out to the console on that one. Just as we expected, as we defined on the get and set for each of those associated properties. Setting context, getting context, wrote it out. And here's the history, so we can see all these changes that we've made, that we've captured as the code was executing, and so on. And we can see every single thing we did to it was written to the logs. And this can be powerful, but do you really want to write this over and over and over and over for every property? Because I don't. I would never do it this way. But when you're doing defined property, you get that flexibility. But it's really cumbersome to manage over time. So that's where ES6 gives us the proxy object. Proxy object, and remember I talked about consistency in interfaces earlier. ES6 gives us the reflect type, and it gives us the proxy type. And they have exactly the same structure. They have different intentions behind them, but there's a one-to-one relationship between the functions on reflect and the functions on proxy. Where on the reflection side, it's about looking and controlling what the objects are, whereas on the proxy side, it's about hooking into those behaviors. So if you were trying to call set, you may control what set does in the classic way with setting get and set, but you don't really get into some of the other capabilities that proxy can give you. And the thing about proxy is that it does what it sounds like it does. It wraps up an object and it hooks into those things as you provide those particular properties to hook into. So where we had to, in the previous example, define a getter and a setter on basically everything we wanted to put on there. Now, with a proxy, we can define it more generally. So now I have const audit object, and it gets an object, and we still have the log that we were seeing before. But instead of returning a constructed object, we return a constructed proxy object. And we provide an initializer to the proxy. So we provide the object that we want to proxy. So whatever we want to monitor, intercept the behavior of, we provide that object. And then we provide get, set, and there's a whole series of these. Again, they correlate directly to what is available through the reflect. So if we wanted to intercept defining a property or removing a property, we could do that. So here, get takes the target and the key, set takes the target and the key and the value. Right? Pretty self-explanatory. It's exactly what you would expect for those behaviors. And we do basically the same thing. Now, one of the things that I think is really nice and they did a good job with implementation on is proxy knows what object it's proxying, and it's not, and so there's a potential for a little bit of an infinite loop, because if I'm going to intercept the behavior on an object and you then go and perform that behavior on the object, it knows that it's already doing it on that object, so it's not going to just keep cycling through it. So we're going to extend this, which then becomes the target. So the object that we're passing in is essentially the target on each of these. And so these functions, as they run, they're going to operate against the object, but in that context, and so you won't get caught in any of those vicious cycles. In this case, we detect what property we're trying to set, and whereas in our previous example, we specifically defined a history property. Well, we don't have to define the history property here because it doesn't exist at all. It's just a proxy. We're faking it. So if somebody tries to set the history object, we're going to say you can't rewrite it. Otherwise, we're going to do exactly what we did on everything. So now we have arbitrary extension, and it doesn't matter how many properties we want on there or what those properties are. this behavior, whether it's get or set, is going to kick in for all of them just by the nature of that proxy. And using that object is essentially the same as what we had before. So I've got audit object, and I'm wrapping up just an empty object. We'll try to get the history. We'll do the first name. We'll do the last name. We'll write it out. Same steps as we had before. Getting history from target. It's empty. Setting first name, setting last name, getting first name. And if I scroll down here, well, now age is undefined. Where did I get it? There. Getting age from target. Well, it was undefined. We see that here. So then, but we still captured it. We don't have an age on our object. We didn't define it before. We've defined it now, so we can set a value on it, but it wasn't there before, but yet we still got the behavior of getting age from target and setting age on target. Because the proxy handled all of that for us. Yeah, so one final example here using the proxy is, I mentioned we can look at other behaviors. So similar type of example, but now, oops, we're hooking into delete property and has. So just like we looked at on reflect earlier, where we can reflect delete property or reflect has, we can proxy delete property and proxy has. And run that. Again, notice here, we set first name, we set last name. So we see that behavior. Let's scroll these a little bit. We set first name, and we set last name, get first name, get last name. I'll scroll through a little further. Let's go find it in here. That reflects delete property. And now there is a delete property in here, and we can see deleting age from target. And we have a series of has. Looking for first name, oh, it found it. Looking for history, found it. Looking for middle name, didn't find it, because we never defined it to begin with. So code generation, not so useful in JavaScript. Reflection, introspection, incredibly useful in JavaScript. And proxy, depending on your needs, could be useful in your projects. So I want to thank you all for your time. I hope you found this useful and interesting, even if you don't take it right away. I think that JavaScript has definitely come a long way in these capabilities. I know that they have certainly changed my opinion of JavaScript in the number of years. Definitely has matured as a language, and I think this has a lot to do with it. So I thank you for your time, and please enjoy the rest of the conference.